EC2 instances. An Amazon EC2 instance is a virtual server in Amazon's Elastic Compute Cloud EC2 for running applications on the Amazon Web Services. AWS is a comprehensive, evolving cloud computing platform. EC2 is a service that enables businesses, subscribers to run application programs in the computing environment. It can serve as a practically unlimited set of virtual machines. Amazon provides various types of instances with different configurations of CPU, memory, storage, and networking resources to suit user needs. Each type is available in various sizes to address specified workload requirements. Instances are created from Amazon machine images. The machine images are like templates. They are configured with an operating system and other software, which determines the user's operating system and the operating environment. Users can select an AMI provided by AWS, the user community, or through the AWS marketplace. Users can also create their own AMIs and share them. Instance types are grouped into families based on target application profiles. These groups include the following. General purpose. A general purpose instance is a virtual machine that is designed to handle a variety of workloads. General purpose instances are optimized to have a high number of CPU cores, on-demand storage, and memory. Some common use cases for general purpose instance include web server hosting and software development and testing. Compute optimized. Compute optimized instances are used to run big data applications that require large amounts of processing power and memory on the AWS cloud. These instances are designed and optimized for running computational and data-intensive applications that require fast network performance, extensive availability, and high input-output operations per second. Examples of types of applications include scientific and financial modeling and simulations, machine learning, enterprise data warehousing, and business intelligence. Graphics processing unit. These instances provide a way to run graphics-intensive applications faster than with the standard EC2 instances. Systems that rely on GPUs include gaming and design work. For example, Linux distribution often takes advantage of GPUs for rendering graphical user interfaces, improving compression speeds, and speeding up database queries. Memory optimized. Memory optimized instances use a high-speed solid-state drive to provide ultra-fast access to data and deliver high performance. These instances are ideal for applications that require more memory and less CPU power, including open source databases, real-time big data analytics, and in-memory caches. Storage optimized. Storage optimized instances are ideal for applications that require high input-output performance, such as NoSQL databases that store and retrieve data in real time. They are also well suited for memory-intensive applications such as data processing, data warehousing, analytics workloads, and log processing. We have also a service that is, we have also a EC2 instance type that is micro. A micro instance is meant for applications with low throughput. The micro instance type can serve as a small database server, as a platform for software testing, or as a web server that does not require high transaction rates. Amazon EC2 instance features. Many EC2 instance features are customizable, including the storage, number of virtual processors, and memory available to the instance, operating system, and the AMI on which the instance is based. The following are the Amazon EC2 instance features. Operating system. EC2 supports many operating systems, including Linux, Microsoft Windows Server, CentOS, and Debian. Persistent storage. Amazon Elastic Block Storage, EBS, service enables block-level storage volumes to be attached to EC2 instances and be used as hard drives. With EBS, it is possible to increase or decrease the amount of storage available to an EC2 instance and attach EBS volumes to more than one instance at the same time. Elastic IP addresses. Amazon's Elastic IP service lets IP addresses be associated with an instance. Elastic IP addresses can be moved from instance to instance without requiring a network administrator's help. This makes them ideal for use in failover clusters, for load balancing, or for other purposes where there are multiple servers running the same service. Amazon CloudWatch. This web service allows for the monitoring of AWS cloud services and the application deployed on AWS. CloudWatch can be used to collect, store, and analyze historical and real-time performance data. It can also proactively monitor applications, improve resource use, optimize cost, and scale up or down based on changing workloads. Automated scaling. Amazon EC2 auto-scaling automatically adds or removes capacity from Amazon EC2 virtual servers in response to application demand. Auto-scaling provides more capacity to handle temporary increases in traffic during a product launch or to increase or decrease capacity based on whether use is above or below certain thresholds. Bare metal instances. These virtual server instances consist of the hardware resources such as a processor, storage, and network. They are not virtualized and do not run an OS, reducing their memory footprints, providing extra security. And Amazon EC2 Amazon EC2 Fleet. This service enables the deployment and management of instance as a single virtual server. This fleet service makes it possible to launch, stop, and terminate EC2 instance across the EC2 instance type with one action. Amazon EC2 Fleet also provides programmatic access to fleet operations using an API. Fleet management can be integrated into existing management tools. With EC2 Fleet, policies can be scaled to automatically adjust the size of a fleet to match the workload. And finally, one instant features is pause and resume instances. EC2 instance, they can be paused and resumed from the same state later on. For example, if an application uses too many resources, it can be paused without incurring charges for instance usage. Let's move to the AWS Management Console. So here we are on the AWS Management Console. There are basically 6 steps while launching an instance. So here we need to select launch instance. In the launch instance, there are basically 6 steps for launching an instance. First is choose AMI. AMI is basically a template that contains the software configuration, the operating system, application servers, and applications that are required to launch our instance. And we can easily select an AMI provided by AWS or user community or the AWS marketplace, or we can select one of our AMIs. Here, we will basically select any of the AMI. So let's select the first one. The second is basically choosing an instance type. AWS EC2 provides a wide selection of instance type optimized to fit different use cases. Instance are virtual servers that can run applications. They have varying combination of CPU, memory, storage, and networking capacity, and give us the flexibility to choose the appropriate mix of the resources for our application. Here we'll be selecting up T2 Micro, and we'll go to next. In the third step, the third step is all about configure instance. Here we configure the instance to suit our requirements. You can launch multiple instances from the same API, request spot instance to take advantage of the lower pricing, assign an access management rule to the instance, and more. Let's go to next. The fourth step is all about adding storage. Your instance will be launched with the following storage device settings. You can attach additional EBS volumes and instance storage volumes to your instance, or we can edit the settings of the root volume. You can attach additional EBS volumes after launching an instance, but not instance storage volume. The fifth step is adding tags. A tag consists of a case-sensitive key-value pair. You could define a tag with a key, name and the value of web server. A copy of tag can be applied to the volumes, instance, or both. And then we can configure the security group. A security group, we know, is a set of the firewall rules that control the traffic for our instance. On this page, you can easily add rules to allow specific traffic to reach our instance. For example, if we want to set up a web browser and allow internet traffic to reach the instance, we can easily add the rules that allow unrestricted access to HTTP and HTTPS ports. We can create a new security group or select from an existing one below. And finally, we have to launch an instance. It may take time. And our instance is now successfully being launched.